All right, we will go ahead and get started here. Appreciate you joining us today for the February edition of the Pigment 101 webinar series. Today we are going to complete the series on micas for long-term durability. We presented this one about maybe 2 years ago when we were halfway in between the data collection process for this subject. Now that we're complete, I wanted to share the full picture for you on this one and how it can be appropriate for other applications besides powder coating. Of course, powder coating was where we did all of the analysis with in here, so we will go ahead and present that to you today. So I am recording this as I do for all of the webinars, and all of those in attendance will receive the link to the recording as well as the PDF. If you have any questions along the way, feel free to use the chat box and I'll address them at the end of the presentation. So with that, I will go ahead and jump off screen and start the presentation. So for color and effects, effects do play a big role in all of our color developments that we use, no matter which application area that you are working in. Effect pigments do allow the manufacturer to develop a very more distinctive color and effect for their formulation, help them stick out in a crowd. The other parts of it, that the physical aspects of mica effect pigments also help to support the balancing act between function, aesthetics, technology, and art. And in this particular case, we will really focus on that function and the technology portion of effect pigments. And as we know, there are a number of reasons for the choice of a color in here. We do know that more likely than not that the end customer who's selecting the color will be more prone to reach out and grab an effect color versus a solid color. And because that tends to be where their some subconscious eye goes to when they are going down an aisle or in a lot for a car. That's usually the impact. So in this particular case, as the picture demonstrates, we are uh, definitely allowing it is more than just chemistry that we're working here. So with this program that we initiated many years ago, we really were matching up the overall chemistry to the application areas. So, especially in powder coating, the colors we're going to are supporting that balancing act between the function, in this particular case, long-term durability, with the aesthetics. So, how does the powder coating application actually look to the end user, to the eye, in here? So that's where we're focusing on. So with effect color pigments, there are many layers that we have options to work with to be able to create that mica effect pigment. And we've talked about several of these in past webinars before. In this particular webinar, we are focusing really on that top layer, the weather treatment that we select for that particular product. And in this case, we are focusing on the chemistry that's used and the thickness or how much of that chemistry is actually used for that particular product to match the technical properties that that product requires. So from an effect manufacturing perspective, once the specific color and size of the mica effect is created, through this process. The material is then um, uh, the surface treatment, I should say, chemistry is then added to the kettle reactor to be able to put that on the final surface of that mica effect pigment. And then, of course, then it is filtered and dried and then blended into the final package. I have an example in the left-hand corner, TEM of a mica effect pigment where you can start to see how they are built in there. So the center piece of that is the mica effect platelet itself. And then on top of that, you see two distinct layers of the metal oxide. So this could be two layers of just TiO2 to create the iridescent versions of this mica, or it could be two layers of iron oxides to create the earth tone types of products. And then the last category, it could be a layer of TiO2 and then a layer of iron oxide to create the golds in the mica effect categories in there. So it is really just a buildup of the metal oxides on top of the layers. And then in this particular case, the final layer on that mica will be whatever chemistry is chosen for that particular product. So surface treatments are a general terminology that we use when talking about pigments, whether they're organic pigments, inorganic pigments, or in this case, mica effect pigments, just to signify that there is something on top of the actual particle itself. Um, there is a difference between surface treatment and encapsulation. And just as the term implies, encapsulation completely covers the entire surface of whatever is being encapsulated, where the surface treatment really only modifies the surface so that there still might be exposed areas. And from a mica perspective, those areas tend to be really just on the very edges of that aspect of it. So it won't be completely covered, but there might be some exposed areas. But the majority of the surface area is treated with the treatment that's selected. What we try to do when developing products is really select the treatment that is tied and will fix the mechanism of that particular failure of that product. So once we identify what the actual failure is, we can then manipulate the correction factor for that treatment so that we complete the surface treatment to match the need of that particular product area. So why is it important with respect to micas is concerned? The silvers and iridescence, they are created with only titanium dioxide. And we know that titanium dioxide will undergo a photocatalytic degradation in there. So we need to be able to protect the surface so that we can minimize the amount of that reaction occurring and ideally try to eliminate that from occurring. The other area is that because there's such a high aspect ratio for mica effect pigments, and we know that they are typically hydrophilic in nature, they may provide more of a wicking action for moisture entry or exit from a film. This is more in terms of liquid coatings as well, so that we can and then the surface treatment chosen allows that to be minimized so that we don't place undue stresses that could result in some amount of delamination in the films that are created. Um, so we set out to do a very in-depth project to understand and document the impacts of several key areas with respect to mica effect pigments and powder coating. Again, this was the area that we found to be the most dramatic in terms of its demands for properties in here. So the main objectives that we went into for this project was to take a look at both chemistry and the amount of that chemistry on the impact of weatherability. Particle size, that's also something important to understand so that we can relate the particle size, which will give you the sparkle effect that you might be looking for, and how that can impact the weatherability. And then lastly, because I mentioned that both TiO2 and iron oxide are used and sometimes in combination for the golds, we wanted to understand what that oxide type and thickness also has with respect to the impact on weatherability. So for this project, we selected a high durability fluoropolymer thermoset master batch for the powder coating. That particular formulation did meet the ALMA 2605 specifications for weatherability. And to that master batch, we then added 2% of mica to each of the samples to that master batch to create the various samples that we use for this evaluation. From a testing perspective, we looked at it three ways. Certainly, time is of the essence with these types of programs. So we did use the ultra accelerated Amaqua testing that's done in the Phoenix area. So it's a high degree of radiation attacking the panels. And then that testing, then we looked at the color and the gloss retention for each of those samples, and that went out for a 12-month cycle. From the Florida perspective, we took this out to 5 years. And then we also, same idea here, where we took a look at the gloss retention and the color retention for that one. And from the xenon perspective, we did look at some select samples out to 3,000 hours in that xenon testing. However, when I take a look at all the data that came in and was able to understand and look at the relationships to all of these, what we found out was the most significant parts of this program was the selection of the chemistry and how much was used on the surface in conjunction with the particle size as well. Metal oxides and thickness were important, but not as greatly important as the other two. And from the actual testing perspective, the biggest impact that we saw was on the gloss retention for these types of samples. And you'll see that as we go through the program. So the first objective was really just to take a look at the chemistry of the surface treatment and the amount of that chemistry that we placed on the surface treatment. So there's a lot here on the chart, and I'll go through it, and then once you see how I've set these up, the rest of the charts will look very similar. So in this particular case, I mentioned that the size and the chemistry were the two key areas in here. So what we found was the finer the mica size, the more impact we see on the weatherability. So what I'm showing you here is the smallest of the micas, the 1 to 15 micron in size, silver in here, so you can kind of get a feel on the upper right hand corner. It's a very fine particle size. Doesn't give you a lot of sparkle. It's more of a smooth surface in here, very little sparkle in there. And then the chemistries we're looking at, we were looking at a chrome containing surface treatment, which we designate with a WR after the product code. And we also looked at the chrome-free surface treatment, which we designate as NXR after the product code. The specifications that I put on here are taken from both the AMA 2605 and 2604 for these particular properties. In this particular case, it is the delta E retention. So both specifications require a delta E of 5 or less for this aspect of it. And then lastly, in the red box, we always are interested to see where our products and potential products fall within the industry standards. So we selected a number of competitive materials to add into the mix just to have that those data points to go along with it. Now, so this goes out to the 12 months. So this is the ultra accelerated data for color retention. The AMA line is at the 5 aspect of it. And what we see is all of the samples except for one at the 12-month period are above that delta E of 5 in there. The one that did fall below the 5 delta E was a chrome containing surface treatment at the highest level of treatment area. All the others were in the above that delta E mark, and I've marked the competitive space with the red arrows. So if we take that same set of samples and we look at the gloss retention, here the AMA specs are different depending on which specification that you're looking for. So the 2604, which is a 5-year specification, is at a 50% retention of gloss. The 2605 is a 10-year, and that requires a 70-degree retention for a superior fluoropolymer-based resin coating system. So same idea here with the same samples. What we see here is there of the all the samples in the study, there were 2 of the WR or the chrome containing samples. The highest and the second highest level did manage to retain above that 70% limit for the 2605. And all of the other ones were in between, either at the limit or in between the 2604 5-year and the 2605 10-year specification. There was one that did not even pass the 2604 5-year one, and that actually was the chrome-free surface treatment at the highest level in there. So in that combination does not work well for this application area. Florida, so same idea here. We're looking at the color retention, delta E. In this case, these are only out to 5 years of Florida. And as I mentioned in earlier slide, the delta E for both specification is still 5. So here we see a wide spread between that one chrome containing high level sample, which is at the very bottom, delta E of less than 0.5. And all of the other samples were a delta E of close to 3 on up in there. And you can see where the competitive materials were versus all the other alternative samples that we had in our project. Again, same idea here. 2 of the chrome-free versions were the highest in terms of the delta E color retention in here. So it's clear that this type of chemistry in this formulation, in this kind of an application area, is not the optimal mix of options to choose from. All right, and so I will go ahead and do it. And I extrapolated the date, some of the data from the 5 months or 5 years to 10 years. It's sort of a stretch in my mind, and I will agree to that. But I did want to see a little bit about where these might go in a 10-year period in here. So we do see that the chrome containing high level version will still be quite low versus the specification of the delta E of 5. All the other samples do look like they're trending towards that level and might even surpass that level. A gloss retention, same idea here. Again, we have the two different specifications depending on which level you're trying to achieve with your formulation. Here we see even at 5 years of Florida, we have one sample that does maintain that above 70% gloss retention, and that's that same 5 year or chrome containing high level aspect of it. And in this particular case, I threw the control in there as well as a baseline. That control has no mica in it at all. So what we see here is even in this particular case, the added benefit of the chrome containing treated mica does help with that gloss retention of the total formulation. And again, we also saw even at the 5 year mark of Florida, we saw that one chrome-free version having a very poor gloss retention, even at the 5 years. And like I did in color retention, I did extrapolate a couple of data points for the 10-year mark of Florida. And we see that also same idea here, where the chrome containing high level sample does look like it's going to maintain that minimum of 70% gloss retention, where the others do not. Oops. The second objective, as I mentioned, is taking a look at the mica size. And just for your reminder, the size of the mica will define how much sparkle you get in your formulation, how much brightness you'll get, as well as what kind of a coverage or hiding aspect of it that you might get from that one. As you can imagine, the finer the material, the less sparkle that you get, but you do get more hiding or coverage with that aspect of it. And then the opposite is true. The coarser you go in mica size. So just to give you a more of a visual, the four that I have starred here are the four that I've included in the data package. Um, we have the one that we just talked about, the very fine one at the 1 to 15 micron size. The next one up is up to 25 micron size, and then up to 60 micron size. And then the largest one that we looked at was up to 100 microns. So same idea here as far as looking at gloss retention and color retention. The first set of data is the ultra accelerated. In each case, we are using the same chemistry. So in this case, the chrome containing chemistry, and each of those are at the same amount. So I chose the mid-range chemistry to be able to compare the sizes together. So ultra accelerated, this is through the 12-month aspect of it, of exposure. So on the left-hand side is the gloss retention. So we start to see what we saw in the earlier slides. The finer the mica, the more impact the gloss retention it has in there, with a lower gloss retention on the smaller ones versus the larger ones. And then on the right-hand side is the color retention, and we start to see something very similar in here. Florida, 5-year Florida, same thing here. On the left-hand side is the gloss retention, and it is starting to, even at 5 years, we start to see the same type of trend that we saw earlier, where the finer the size, the more the impact of gloss retention, and in this case also color as well, to be able to do this. Again, this is the mid-range chrome containing surface treatment that we were looking at. The earlier slides that I showed you, the best of the best, if you will, was at the highest level of chrome containing surface treatment. The third objective was to take a look at the metal oxide on the surface in here. So there's two types that we're looking at, as I mentioned at the very beginning. For the TiO2, when we change the thickness of the TiO2 on the platelet, we start to change the color. So the thinnest will be the silver, then the golds, then the reds, then the blues, then the greens. On the iron oxide only is the earth tones. So the thinnest is going to be the bronze, the medium, then copper, then maroon, and then there's another one in there that's red. If we combine the two to get the golds, the TiO2 is always going to be on the inner layer, the layer that's right next to the mica itself, and then on top of that is the iron oxide. So here we are. The next objective was really to understand more about the choice of the metal oxide, and then the thickness, which then describes the actual color itself. So similarly, these are all the same surface treatment. Again, it's that chrome containing aspect of it at that mid-range. The first chart here is the ultra accelerated. On the left is the gloss retention. On the right is the color retention. And what I did here is I also threw in a size difference in here. So I have the very, very fine, the 1 to 15 micron, and then the mid-size range or the standard size range of the 10 to 60 micron size range for these types of things. It does prove the same thing that we saw in the earlier chart, that the smaller the particle size, the more impact the weathering has, and the more impact the choice of surface treatment has in here. Now, when we take a look at the thickness of the layer, so here it's just TiO2 in this example, where we have the silver at the thinnest and the iridescent gold, the next level of TiO2 on the surface. And in both cases, we see less impact the thicker the TiO2 has. So less of an impact of that photo degradation aspect of it in these examples. If we then also look at the Florida, same idea here, so same chart. In here, we start to see, again, that same impact by size. Smaller is more impacted by the exposure and the size as well. Shifting gears a little bit as far as the types of the metal oxides in here. So this chart, what we're looking at is all of these are the same size of mica. They're all 10 to 60 microns in size. They all have the same chrome containing treatment, and they're all the same amount, that mid-range. What I have is the bottom one, the silver, which is just TiO2. The middle one is the bronze, which is the lowest level of iron oxide, just iron oxide. And then the top one, being a gold, has both the TiO2, the first layer, and iron oxide, the second layer. So in this particular case, for the ultra accelerated at this size, the gloss retention on the left, Doesn't seem to be a lot of difference in there. We start to see some differences with just the silver versus the other two. And same idea with the color retention as well. Florida data, because it's only 5 years, there's less of a difference in this comparison. That's both because of the choice of the metal oxides as well as the size of the mica itself. So, summarizing all of what we just discussed here, the pearlescent pigments are going to give you that nice effect in your formulations, but it's always good to understand the impact that they can have and how to address the needs, the technical needs of your formulation to match those with the actual product itself. Unfortunately, there's no universal treatment. I would love to say that there was, whether it's for an application or for a product. So what we try to do on the formulation and R&D side is make sure that we formulate these products to meet the most stringent areas in all application areas so that we can offer the best type of product to meet as many performance levels as we can with these products. Ultimately, the ideal position would be customizing everything for everything. Obviously, that's not a realistic approach, but the more information we gather from the applications and from the performance areas, the better we can build our portfolio to be able to cover as many application areas as possible. As you probably saw throughout here, and as I started off the presentation, that the smaller the particle size, and they are always going to require that the highest amount of surface treatment of the correct chemistry. Now these, as I mentioned, these were dialed in for the powder coating chemistry or formulation. However, that was why we did the same approach with the chrome-free version in there, just so that we can match the chemistry and the application as well. Just as I just messaged, selection of the chemistries is critical. We have to be careful with those TiO2 iridescent type micas and making sure that we approach it in the best manner that we can with the application. With the gold, where the mica is first covered with the TiO2, they don't seem to have that same impact because they're protected with the iron oxide, sort of another layer of surface treatment, if you will. Ultra accelerated data versus Florida data, certainly there's all different opinions on that one. My evaluation of that data is pretty close to it. It gets a little closer near the longer term aspects of it than the shorter term. So it's more of a curve versus a straight line in here. But the real key here is to make sure that we are matching the surface treatment to the performance. So I mentioned earlier that this was geared towards powder coatings as being one of the more severe application areas for this particular program, and that's why we chose it. However, the learnings that we take away from this can be applied to a lot of different other application areas. And so I've just listed a few of them here that you might take away and be of interest in. So on the liquid coating side, two areas that came to mind for me from my previous life is the monocoat or single stage types of paint systems where there's no clear coat there to protect the surface, the coating itself. What this allows you to do is now you're open up new color spaces and design opportunities for these types of paint systems, because now you can better protect the actual formulation itself from weathering without having to go to that more expensive base coat, clear coat type of scenario for those application areas. In the traditional base coat clear coat, or if there's a base coat tinted clear coat, think of your white pearl cars out there. They're always going to have a pearl in that clear coat on top of the TiO2 base coat area. There's an opportunity to potentially lower the amount of inhibitors that are used in the system, and that could also then provide a lower total formulation cost for that particular system. Other application areas in coatings, architectural paint, where you need to be outside. These also then, because there is no clear coat for those as well, it does offer up new color spaces and design opportunities in those types of areas. In particularly some regions with intense sun, you can certainly take advantage of these types of areas. And one area in particularly that you can provide a new look to is like a textured stucco impact, that you can take advantage of all of those ridges and valleys to impart a softer shine effect in that particular effect. And of course, I can't leave out plastics. There are a number of items that are created with plastics that are exterior only in their application areas. A couple of things that came to mind is vinyl siding, where you might want a little soft luster effect. Window frames come to mind. Also, there are a number of physical articles that are out there that are used for outdoor use. Again, that also opens up new spaces and opportunities for unique designs to be able to do that and still get the properties that you're looking for. So with that, I will open it up to any questions that you might have about this topic. And if you have any questions, go ahead and add them to the chat box. Okay, I don't see any questions here, but that's okay, certainly okay. If you come up with a question after you get the information, just shoot me a line and I'll be happy to help. I do appreciate you taking the time to join us today, and look forward to seeing you next month for our next installment of the Pigment 101 webinar series. And with that, I will say thank you and have a great rest of your day. Take care, everybody.